It's an honor to present to the admission committee two of my projects that I have been working on during these months, which I think they demonstrate my skills and knowledge in petroleum sciences and programming languages, which I hope will be of great value for the university. I will start with the machine learning project, which is at an early stage, so it lacks of some back-end functionalities. This is because I'm only focused on the load and display of data first, the front end and the communication between the plugin modules too, the data modules and the user interface modules, among others. As you can see, there's a collection of views here, different view tabs, models, different buttons, and database tabs on the left. These database tabs don't have functionality at the moment. Here at the left side, we have an import button, which brings us an import wizard. We had many options to import different kinds of data, from seismic, here, to single traces, wall information, to velocity data here at the end. Database button. Here, I'm thinking to implement a database management after I finish all the scientific work first. Interpretation tool. Well, I would like to clarify that my primary purpose about this software is not to implement an interpretation suite, so this is not focused on interpretation, but mainly for AI and machine learning implementations and data sciences analysis of geological information. Nevertheless, my first intention these past months was actually to create a 3D seismic spectral decomposition software with color blending here, as you can see here in this to-do window. So I will be working on this in December. Artificial intelligence tool. In this model, I put all the possible implementation of AI with geosciences that I have been thinking of during my career. Here, I put all my ideas that I'm going to develop during these months and during my possible master studies. Also, I gathered some interesting ideas from my colleagues and friends in the sciences that could be an important contribution to this project. So, I will always have fresh ideas during the making. Data science tool. Well, this is an interesting problem. In my opinion, data sciences and geosciences is a very old concept, and many algorithms that we use on a daily basis, such as indicators for geological models or some petrophysical and core analysis, have many concepts on data sciences included into them. So, in here, instead of adapting some data sciences procedures into geological analysis workflows, a thing that already exists, I'm trying to implement the standard and classical data sciences project workflow to geosciences problems. I noticed that this approach requires a more creative attitude of the geoscientist community towards the data and a bit of managerial skills. That means that I'm forcing the user to think more like a data scientist rather than an interpreter to give a less biased result. I see this concept more versatile, but I have to test it before a lot. For example, here in the data sciences tool, I followed the structure of the traditional workflow for data analysis, from data gathering, feature engineering, here, feature selection, visualization, modeling, and testing here. The first model that I'm implementing now is the visualization one. For testing this model, I created an artificial data collection related with drilling in geosciences, where I'm talking about production reservoirs around the world. You can see that information here. Please note that I invented this data. Well, I will load this data and I will show how this model works. I select here feature. I want to know about the dry and oil wells. I select the area and I select only an area. Then I filter the data and I plot my results here in data science view. Okay, if I want to explode a slice, I select oil because I want to know about the oil. And if we want more areas, I select more areas. Now I plot more areas here. And now I know the behavior of this one, each one of these reservoirs. I can change to bar plots and horizontal bar plots here. And I put more information in these bars. But I always prefer the pie chart. I think that they are more informative. And I put gas here. I want to include gas. I filter the data frame. And now I have more feature in my pies. Now I will show the CY implementations here. Import button. Now I want to read a CY file. I'm taking the data from Alaska 2D. Data is read it. Okay, and I want to see my 2D seismic here. So my 2D seismic is loaded. If I want to load another seismic, not considering the geometry, without considering the geometry. Okay, read it this one. Seismic change. If I want to read 3D seismic, I always select 3D seismic here. Select my file, my 3D seismic, stratum. And then all the data about inlines and acrolines are loaded in the computer memory. And now I will plot my data. Time slice here. And now single traces. This is a project that I'm working with a friend in the Middle East about hydrophone responses. Here, load the data, read the seismic, and here I have different traces, each one from a different color. I coded this project in Python using a variety of libraries well known for their usage in data sciences. Here, inside the code, we can see which libraries I used. The first one, PyQt5. This is the user interface library, which additionally had a Qt designer for graphical user interface construction. Now, this is the Qt designer. Here I built all the user interfaces for this program. The second in importance is NumPy. It's the multi-dimensional array library and matrices handling. The third one is Pandas, the data framework library for data sciences and data manipulation. Another one is Matplotlib, the scientific and data sciences plotting library. And the most important is Segway.io. This is the Equinors Segway Python library for seismic data input and output. So, in conclusion, I explain here the progress of my project, the purposes about it, and I've shown you some of my programming skills. Thanks a lot for your time.